Assalamualaikum and good morning everyone. We are from Group 4 and today we will be presenting our project called Malware Analysis of Voice Memo.exe. In this presentation, we will discuss the selected malware sample, the analysis finding, the indicator of compromise, and the potential threat by this malware. I will begin by introducing the malware sample overview. Our selected malware sample is voicememo.exe, which is a Windows PE32 executable that uses the x86 32-bit architecture. It was developed using the VB.NET programming language and required the Microsoft.NET Framework 4.0 to execute. This malware sample was obtained from Malware Bazaar, which is an approved malware research repository. Based on our initial analysis using Detect It Easy, the malware was identified as a suspected variant of Venom Rat. Venom Rat is a type of remote access Trojan that allows attacker to gain unauthorized remote access to an infected system. Once a system is compromised, it may perform various malicious activities such as collecting sensitive information, manipulating system functions, and communicating with a command and control server. Moving on to the reason why we selected this malware sample. First, it was selected because it showed characteristics associated with Venom Rat and contained several suspicious references to Windows system tools such as Task Manager, Process Monitor, and Registry Editor. This reference may indicate possible defense evasion or anti-analysis behavior. Next, VirusTotal associate the malware with several military attack techniques, including command and control, information collection, and registry modification. No, it showed that the malware may have capabilities to communicate with attackers, gather information, and modify system settings. Therefore, the main objective of this analysis is to identify the malware characteristics, extract indicator of compromise, analyze suspicious things and potential behavior, and understand its possible impact on system security and user data. Thank you.
So now let's continue with for the next part, which is what analysis thread that we choose for our malware. So my name is Majdi Ahmadi, with Majdi number 2417185, and for my part I will explain about we choose about the analysis thread that we choose, which is the static malware analysis. So first of all, what is static malware analysis? Static malware analysis is a process of examining the suspicious file without executing it. The keyword is without executing it, which means it will be a lot safer as we don't need to run the malware itself, as most of the malware only will be started or will be functioning if we execute it. So I will list down several advantages of using the static malware analysis before we dive deeper. So the first one, the malware does not need to be executed, making the analysis safer. It also will reduce the risk of infecting the computer and analysis environment. Like we use the isolated environment virtual machine. It also will help identify suspicious string, URLs, IP addresses, file paths, and commands. It will allow analysts to examine file headers, imported function, section, and embedded resources. It also will help analysts to understand the sample before conducting the dynamic analysis. So it is useful for generating file hashes and indicators of compromise, which is the IOC, or we call it IOC. And the last but not least, it can reveal the malware structure and possible capabilities. So now let's move to why actually we choose string analysis for this specific voice memo.exe. So the first one, we choose this analysis because the sample is suspected to be a Venom Rat variant, which is a remote access Trojan designed to communicate with an attacker and control an infected system remotely. So this string analysis can help us reveal the command first. Can help reveal the command and control information, which means suspicious IP address, domain name, URLs, port, or server name may show how the malware communicate with its attacker. So this analysis also will reveal malicious command and function. Strings may contain command related to downloading files, executing program capturing information, controlling processes, or modifying the system. Also, this analysis can help us reveal the system and persistent indicators. The malware may contain registry paths, file paths, startup locations, scheduled task name, or mutex value used to remain active after the computer restart. It also will help us reveal the information stealing indicators. For example, strings may reveal references to password, browser data, screenshot, clipboard content, system information, and user credential. Credential. And last but not least, this string analysis will help us to reveal the useful indicators of compromised IOC, which means extracted file names, like extracted file names, domains, IP addresses, key, registry key, and other unique value can help security analysts like us detect the malware on other system. So therefore, string analysis is suitable because it provides an initial understanding of the suspected vulnerability, possible capabilities, and communication behavior without executing the dangerous file. However, encrypted or obfuscated string may require further analysis. So that's all for my part. I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Ariff and my metric number is 2412875. I will be guiding you through the key findings and indicator of compromise for host memo.exe. Starting with defense evasion, our static analysis revealed that this malware actively target the security tools to avoid detections. As you can see in the guide screenshot on the slide, we filter for .exe strings and found hard-coded references to 11 administrative and security utilities. This includes Windows Defender components like msmpeng.exe and miss.srv.exe, as well as analysis tools like Process Hacker and Taxmgr. This proves the malware is designed to actively impair system defenses and terminate monitoring tools. Okay, next, moving on to reconnaissance and persistence. To understand the victim's environment, the malware uses Windows Management Instrumentations or WMI queries. Specifically, it uses the query selects from Win32 to fingerprint the hardware and operating system. Once it knows the environment, it secures the foothold. We found direct interactions with Internet Microsoft Registry APIs, the binary use called like create subkey and delete subkey tree to manipulate the registry hives, ensuring the malware executes automatically upon system startup or disables further security features. Next is, once the malware collects data, it needs to exfiltrate it. On the right side of this slide, you can see our Hydra function tree analysis, which is identified network communications function like get, sensing, and sender. This allows the malware to maintain a live beacon to the attacker's command and control server. However, to evade network traffic inspection and reduce its footprint, it compresses the stolen data first. As shown in the virus total match on the slide, it used the .NET System I/O compression gzip string library to archive the data before sending it out over the application layer. Finally, here is the summary of indicators of compromise. On the top right, we have included the terminal outputs from our hash generation. The MD5 and the SHA-256 hashes listed here serve as the unique digital fingerprints for this specific vulnerable variant. We have also mapped out the primary suspicious DLS it imports, such as mscore.dll, which confirm its .NET dependency alongside core Windows system libraries like kernel32.dll and ntdll.dll. Identifying these IOCs is a critical step as they allow us to deploy accurate network and endpoint defenses. That's all from me. I will now pass the presentation to the next member to discuss the specific tools we use and examine further evidence in detail.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Izzat Rosli. So today I will be presenting the tools used and evidence section for our malware analysis project. To analyze the malware sample, voicememo.exe, we use three main tools: Detect It Easy, DIE, Ghidra, and VirusTotal. First, we use Detect It Easy, DIE together with the Linux file commands and hash utilities. The purpose of this analysis was to identify the malware's file type, architecture, programming language, and generate unique hash values. From the results, we found out that the malware is a PE32 Windows executable designed for 32-bit systems developed using VB.NET and built on the .NET Framework 5.0. DIE also heuristically identified the sample as a possible Venom Rat variant, suggesting that it may function as a remote access Trojan. In addition, we also generated MD5, SHA1, and SHA256 hash values, which serve as indicators of compromise and can be used to identify the malware in other systems. From this analysis, we concluded that the malware is a suspicious Windows executable with characteristics commonly associated with rat malware. And then next, we use Ghidra to perform reverse engineering analysis without executing the malware. Through Ghidra, we identify imported DLLs such as kernel32.dll, user32, and ntdll, indicating that the malware interacts with the core Windows operating system functions. We also discovered references to security-related tools, including Task Manager, Process Hacker, Process Monitor, and Windows Defender. These references suggest that the malware may attempt to detect or evade security software. Most importantly, Ghidra revealed communication-related functions such as send info, and get send sync. These functions indicate that the malware may be capable of communicating with a remote command and control server, which is a common feature of remote access Trojans. Finally, we use VirusTotal to gather threat intelligence and map the malware's behavior to a MITRE ATT&CK framework. VirusTotal associated the malware with several techniques, including modify registry and boot or log on auto-start execution under persistence, data from information repositories and archive collected data under collection, impair defenses and virtualization or sandbox evasion under defense evasion, and process discovery and system information discovery under discovery. This mapping suggests that the malware may collect information, maintain persistence on a victim system, and attempt to avoid detection by security tools. Overall, the attack results support our finding from DIE and Ghidra that the malware exhibits characteristics commonly associated with remote access Trojans. Finally, by using Detect It Easy, Ghidra, and VirusTotal, we successfully identified the malware structure, extracted important indicators of compromise, and analyzed its potential behavior without executing the sample. Our findings suggest that the malware is likely a Venom Rat-based remote access Trojan with capabilities related to communication, information collection, persistence, and defense evasion. I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Al-Hafiz by Alwi 2413879. So, I will present about the part of conclusion. Move in ships closing. This is where the file voicememo.exe disguises itself as a harmless voice note, but it's actually a dangerous remote access Trojan, Venom Rat variant. Small but little, 64.50 KB. Despite its tiny size, it packs a full suite of malicious features designed to steal data, record system info, and spy on the victim. For the third one, active sabotage. It is programmed to hunt down and kill security defense, explicitly targeting Windows Defender, Task Manager and antivirus tools to stay hidden. And for the last one is data smuggling. It quietly collects system info using Windows management tools, compress it into a gzip archive to shrink the footprint, and prepares it for exploitation to an attacker's server. Insight for this malware: to stop this threat, defense must be active to every layer. For the first one, at the network edge, block the malware unique digital fingerprints MD5 SHA-256 hash at the firewall to stop it from entering the network or talking into commander. On the device, keep tamper protection enabled on antivirus software so the malware cannot forcibly shut it down and restrict administrative registry access. For the user, enforce strict email filter to block unapproved .exe attachment and train team members never to run unexpected executable file. And for the last one, emergency protocol. If an infection occurs, immediately isolate the machine from the network to cut off the attacker's remote control before wiping and restoring the system. So that's all for me. Thank you.